Hello, my name is Laurent Mertens and I will be presenting our paper Learning to Classify Users in the Buyer Modalities Framework to Improve Click-Through Rate. This work was done together with AdRelevance, a startup company that wants to use AI to show each visitor engaging ad content and get more leads and sales. And the way they want to do this is by exploiting something called the Buyer Modalities Framework. The Buyer Modalities Framework is a framework that divides people into one of four types or profiles based on how they make their purchasing decisions. You can see the four profiles here: competitive, spontaneous, methodical, humanistic, and each profile has their own specific information need. For example, say you want to buy a new car, then the humanistic profile will be very interested to know what current owners think of your car, whilst the competitive profile will want to know how much faster than the competition it goes. So the general setup is the following. We want to collect user website statistics and then use this data to train a predictive model that assigns a profile to each user on your website. As predictive model, we went with a random forest. The work described in the paper was a proof of concept that we did together with a commercial partner, Coopmans, which owns amongst others two websites, Autogids and the Moniteur Automobile, which essentially propose the same content but in Dutch and French. And as you probably guessed, essentially they are online car magazines. What you see here is a screenshot of Autogids with on the right a banner ad for, in this case, Volvo, but this is unrelated to our work. This screenshot was taken after we completed our work. But it was the ad placed at that position that we wanted to optimize. So the idea is to have a unique variation of the same banner ad for each buyer modality profile. And then when our system predicts a profile for a user, the ad server will display the corresponding ad variant to this user. The workflow consisted of two phases. A first phase where data was collected that was used to train a predictive model, followed by a second phase where the trained model was used to make real-time predictions that were then used by the ad server to deliver the ad variant tailored to the predicted buyer modality profile to the end user. So the data collection in phase 1 was done by a third party. What happened was, for a specific ad, 4 variations were created, one per buyer modality profile. These were then displayed randomly and clicks were registered for each variant for a total of 250,000 impressions. The bar chart in the middle of the slide shows the view distribution per ad. As you can see, it is highly imbalanced. Initially, the intention was for the viewing to be, the number of views to be normally distributed, but something went wrong technically and we ended up with a highly imbalanced dataset. The idea is that when a user clicks on an ad variant, we consider the user to belong to this specific profile. In other words, the ad variant clicks determine our targets to train our model with. Sometimes the user would click more than one ad variant, in which case we would use this user as a target for all variants clicked. The table on the bottom displays a number of clicks collected for each website and per ad profile, and so as you can see, in total we collected 370 positive samples. This is a short excerpt from the raw data. Essentially, it contains the following features that we use to train our model with. On the left, we have a unique user ID, so each row corresponds to a unique user, the number of sessions for this user, the number of times basically you visited your website, the average session duration in seconds, average time spent on page per seconds, the number of page views, the number of times the user interacted with a specific content type. So in total, 7 content types were defined. For example, a content type might be the photo gallery or user review, stuff like that. The number of times each ad variant was shown to this particular user, and the number of times the user clicked on an ad of type 1, 2, 3 to 4. The first question we asked ourselves is, can we distinguish between users that clicked on an ad and those that didn't, using the data and features at our disposal? This table shows the average results from an experiment with 200 random forests with 200 trees, each of depth 3, where each run uses an 80-20 train test data split. The data consisted of all positive training samples, each time randomly completed with as many negative samples. As you can see from these results, discriminating clicking from non-clicking users is a lot better than baseline at around 66% average, but also far from perfect. Next, we checked if it is possible to discriminate between users clicking on different ad variants. If this were not the case, then this would indicate that the different ad variations didn't have any effect. Luckily for us, using the same 200 forests of 200 trees at depth 3 and 80-20 train test split, the results indicate that the variations did have an effect, and so this indicates that the different ad variations do indeed appeal to different people with different website surfing behavior. So the final question of course becomes, can we classify users into one of the 4 buyer modality profiles? The idea is that everyone can be categorized into one of the profiles, so we trained a multi-class classifier using all positive samples that would not predict a neutral profile. The model always returns one of the 4 buyer modality profiles. We again used a random forest, this time a multi-class classifier, with 200 trees, and the results shown here are average results over 200 forests using a stratified 80-20 train test split. We checked 2 different depth sizes, trees with depth 3 and 10. As you can see, the models perform better than the baseline, which in this case is 0.25. There are 4 profiles, so if you randomly assign a profile to someone, you'll have a 25% chance of being right. Now, as is to be expected, the model with depth 10 tends to learn the training set by heart, but we still used this model for the second phase, despite it generalizing less well, as can be seen by its lesser performance on the test set than the depth 3 model. And the reason is that with the low number of positive samples that we had, we hoped the model would encode these samples as stringent prototypes rather than using a more diffuse model. So in other words, this was an intuitive decision and a bit of a gamble. This brings us to phase 2, where we deployed the model and used continuously collected data to make real-time predictions. So this time we collected all the necessary data ourselves, and the general overview is as follows. A JavaScript script would be running on the AutoHits and Moniteur websites and collect all necessary data. This data was then sent to a PHP server that would write the data to a SQL database. On the prediction side, the website would send a prediction request for a specific user ID to a CherryPy server, prefaced by an Nginx server, and the CherryPy server would then reply with its prediction. These are the concrete steps for the prediction phase. The AutoHits or Moniteur website would send a prediction request for a specific user ID to the server. The server would then check if the user was known in the database, and if so, if the user has at least 3 sessions, all data for this user would be collected from the SQL database, from which the features would be computed, which would then be sent through the model. And if the score for the highest scoring profile exceeded 0.35, this profile would then be returned. In all other cases, a neutral profile would be returned. The target was an ad for a specific Kia model, which ran for 2 weeks on AutoHits and another 2 weeks on Moniteur. In total, 5 variants of this ad existed, 1 neutral ad and 4 ads tailored towards each buyer modality profile. The table on this slide shows the number of ad impressions on each website, where baseline indicates the neutral ad that was displayed without the use of our system. So this serves as a baseline to compare the performance of our system against. Note that using our system, the neutral variant would also be showed if either the user was unknown or our system returned the neutral profile as explained on the previous slide. As a result, it turned out that the click-through rate using our system was on average 33% higher than the baseline click-through rate between AutoHits and Moniteur. Note that unfortunately, due to contractual obligations, we are not allowed to provide the exact click-through rates. But there's more. After this first run, AdRelevance and ProDepress decided to hold a second run in which KU Leuven was not involved, using the same model as before, with an ad for the same brand but a different car. This time, the click-through rate improvement was even much more dramatic, with plus 129% for AutoHits and plus 94% for Moniteur, compared to the same baseline as the previous result. But because no new baseline was established, we only consider these numbers as anecdotal evidence. So that was it for me. Thanks for your attention, and I'm looking forward to your questions.